Greetings, Berlin. Welcome to the 6th Annual World Conference on Climate Change 2025. Today, we'll rediscover overlooked technologies that clean water and generate energy sustainability. This presentation reintroduces the inline water treatment system, a technology that is 40 years old. I will also introduce the MT water motor. These two technologies can provide meaningful water management solutions that are low cost, eco-friendly, and mostly unrecognized. Imagine converting a small polluted stream into clean water and power for the community, like those along Germany's Spree River. So let's dive into these lost discoveries and see how they can shape our future. Harvesting the potential energy of water is a game changer for global energy production. This slide highlights how we can achieve greater efficiency, sustainability, and impact in water-rich areas. Now, these solutions could power rural communities or industrial hubs like Berlin. Just think of a small polluted river generating enough energy to light a village with or without carbon emissions. Now, the potential energy of water is truly a game changer for global energy production. This slide highlights how we can achieve greater efficiency, sustainability, and impact water-rich areas. These solutions could power rural European communities or industrial hubs like Berlin. Think of a small river generating enough energy to light a village without carbon emissions. Now, harvesting the potential energy of water can impact the future of the world's energy production. Water's potential energy is a game changer for global energy production, period. This slide highlights how we can achieve greater efficiency, sustainability, and impact on water-rich areas. These solutions could power rural European communities or industrial hubs like Berlin. Think of a small river generating enough energy to light a village without carbon emissions. This is a schematic of the inline water treatment system, or simply the ILS. It's designed to treat water using gravity or electricity. It needs 50 feet of elevation, making it ideal for hilly regions or industrial sites. There's no external power required, just water doing the work. This could fit seamlessly into Germany's mining infrastructure for clean water. Now here's the inline water treatment system, or simply the ILS. It's designed to treat water using gravity or electricity, pumps or gravity. It needs just 50 feet of elevation, making it ideal for hilly regions and industrial sites. No external power, just water doing the work. This could fit seamlessly into Germany's mining infrastructure for clean water. Now, the jet pump is the heart of the ILS. By simultaneously mixing air with or without chemicals into the water flow. It's shown here through the suction port. It's an off-the-shelf item technology and requires 20 psi of water pressure to create the venturi or suction action that pulls in air and allows for liquid and dry treatment additives to be introduced simultaneously through the suction port. Note the back pressure can reduce suction and is a key consideration in the design of the vertical mixer. These pumps are constructed of various alloys and PVC. However, unlike different alloys that come in a broad range of diameters, the largest diameter available for PVC pumps is 3 inches. PVC will not corrode and can easily be cleaned and reused numerous times, thus extending their long-term replacement costs. Now, the jet pump is the heart of the ILS. By simultaneously mixing air with or without chemicals to the water flow, it's an off-the-shelf technology and requires 20 psi of pressure to create a venturi action or a suction action that pulls air into the pipeline and allows for liquid or dry treatment materials to be introduced simultaneously through the same suction port of the jet pump. These pumps are constructed of various alloys and PVC. However, unlike different alloys that come in broad range of diameters, the largest diameter for a PVC jet pump is 3 inches. PVC will not corrode and can easily be cleaned and reused numerous times, thus extending long-term replacement costs. Now, although the jet pump is the heart of the ILS, the static mixer is the soul of the technology. Combination of air and water entering the vertical mixer creates bubbles that rise through the trickling media, which in turn creates a micro bubble-like effect, displaying a beer foam appearance at the discharge. The polymer construction of both the jet pump and trickling media can easily be cleaned by submerging the components in vinegar for a period of time to remove gypsum scaling. One previous industry application of the ILS utilized duplicate hardware. Since it's easy to replace jet pumps and mixer components individually when scaling built up to a certain point, the component would be replaced with a clean unit that was previously cleaned with a vinegar bath or mild acid bath. Components are recycled between in-service and inexpensive mild acidic cleaning. The recycling capability of components reduces maintenance and replacement costs. The ILS isn't just a theory. It's been proven in real-world mines across the U.S., from California's metal mines to Pennsylvania's coal mines. It tackles acid mine drainage effectively. This means cleaner water and healthier ecosystems. Imagine this technology restoring Germany's mining regions to pristine conditions. Now, the ILS isn't just a theory. It's a proven in real-world mines across the U.S. From California's metal mines to Pennsylvania's coal mines, it tackles acid mine drainage effectively. This implies cleaner water and healthier ecosystems. Imagine this technology restoring Germany's mining regions to pristine conditions. Now, the ILS treats water right inside the pipes, with or without chemicals, and for maximum efficiency. Its compact design fits existing infrastructure, from mines to factories. It's versatile enough for an urban or rural applications. Picture this treating Berlin's Spree River with a minimal footprint. Now, the ILS is a powerhouse. It combines aeration, mixing, and chemical dosing in one system. In just one system. It handles diverse water types, excels at removing iron and manganese, and cuts costs significantly. Its flexibility makes it a go-to for mines and industry if they knew about it. This could save millions in global water treatment budgets. Now, just one more slide with the ILS. And it's part of the world's first semi-passive underground treatment system. It couples the ILS with a line feeder, both powered by one pump using existing infrastructure. It's efficient, sustainable, and groundbreaking. This demonstrates an effective coupling of two water-powered technologies powered by one electric pump. The following discussion will focus on the development of a water motor that can power multiple water-powered technologies. Berlin, allow me to introduce to Europe the MT water motor. Meet the MT water motor and watch the movement without an attachment and see how it turns water weight into mechanical energy with just 13 feet ahead, 9 gallons per minute feed rate in a 30-gallon tank with a pin-activated discharge. The energy in this situation is being absorbed into the wood cribbing. Watch the levers rock like a seesaw. Imagine driving pistons or shafts with no fuel other than water. It's simple yet powerful, using only gravity. Now think back a couple slides showing the industrial application of the ILS and how they were lined up side by side as a means of increasing the system's flow capacity. The water motor can expand flow capacity in a similar manner by adding additional levers side by side on a single A-frame or with additional A-frames. The use of multiple water motors in parallel can smooth out and eliminate the cyclic energy output. And furthermore, the MT water motor is capable of reharvesting water weight due to its fixed head operation of approximately 20 feet. For example, if the water source is 100 feet above drainage, energy can be harvested at 80, 60, 40, and 20 feet. That's 4 times. And each harvest can produce various products. Water pump, a compressor, turning a shaft for a generator or a flywheel. Now the water motor's power scales with the lever geometry, meaning the tanks. A 5-foot high tank with a 2-foot radius generates nearly 4,000 pounds of force. A 4-foot radius generates up to 31,000 pounds of force. This means you can customize for any task from infrastructure to factories. It's kind of like Archimedes designing for the 2025's energy needs. Now the water motor also works horizontally, using a bidirectional flow for power. This setup adapts to tight spaces or flat terrains, maintaining efficiency. Pumping water is only one technology to harness low head water, but it may be perfect for the European rivers with adequate elevation. This Excel model lets us size the water motor by tweaking numerous variables like flow, check valves, height, stroke, etc. It ensures the system fits any application from small pumps to large generators. It's flexible and user-friendly. Engineers can rapidly customize this for Berlin's water systems. And this is a screenshot of the Excel model used to create the following data that I will present. The orange cells in the spreadsheet represents the variables such as lever length, fulcrum height, tank sizes, etc. Our model shows how much water the motor can raise to different elevations, shown in this table. At 50 feet, 32% of 500 gallons per minute, or 156.7 gallons per minute, is raised with higher yields at lower heads. This proves efficiency in real-world conditions. Imagine the MT water motor lifting water globally for beneficial use. It's also important to note that this system works with a single or dual water source. A single source results in pumping a portion of the water flow to a new location, returning the rest to its origin. Dual sources keep water, weight, and discharge flows separate, maintaining water quality of each source. One source, regardless of quality, does the work and drives aeration, chemical addition, or water lifting, while a second water source feeds the pump and is redirected. This table describes storing raised water in reservoirs for reuse in treatment, energy generation, or other applications, creating a closed-loop system. Regardless of energy source, raising water takes time, and it generally requires storage space, whether it be temporary or permanent. This table shows the time required to raise water in terms of acre-feet or gallons at various pumping rates that the MT water motor is considered capable of providing. Now, raised water isn't just stored. It's a resource for multiple uses, shown in the slide above. From cutting power costs to creating wildlife ponds, it's versatile, sustainable. It supports both industry and the environment. Picture EV charging stations in rural Germany powered by a stream. The water motor is a low-cost, eco-friendly powerhouse. It uses gravity to generate energy with no emissions and versatile outputs. Its simplicity ensures long-term use. This could be Europe's next step in green energy. Future efforts will focus on integrating commercially available technologies such as compressors, hydraulics, generators, and flywheels, and more with our motor. The coupling of various technologies will expand its use for energy storage and many practical applications. Simply put, the MT water motor is a platform for innovation. To the World Conference on Climate Change attendees, I say, let's collaborate on innovation. Thank you. Future efforts will focus on integrating commercially available technologies, such as compressors, hydraulics, generators, flywheels, with our motor. The coupling of various technologies will expand its use for energy storage and many practical applications. Simply put, the MT water motor is a platform for innovation. And to the World Conference on Climate Change attendees, let's collaborate on innovation. Thank you.